Okay, speaker has already connected with us. Let us start this day with a prayer.
It is in the early morning hour that the unseen is seen, and that the far of beauty and glory, vanquishing all their vagueness, move down upon us, till they stand clear as crystal close over against the soul. Good morning. On behalf of the PG Department of Computer Science, Holy Cross College, Trichy, I render a very warm welcome to all of you. It's my immense pleasure welcoming you all to the 5 days faculty development program on integrated data analytics, the tools and applications across industry verticals. Prayer is the nearest approach to God. Never doubt the power of prayer. Prayer changes everything. Sometimes all it takes is just one prayer to change everything. Time spent in prayer is never wasted. To begin this day orderly, let us first invoke the presence of the Lord Almighty with a prayer song.
Me too.
As we gather in this place today, Holy Spirit, come and have your way.
here in the hard disk. Is there any other way to avoid it?
So we can use RAM for that in memory.
Yes, we can use the RAM for it. Yes, very good. Right. That's the way. So initially they use the hard disk. The hard disk takes huge time to read and write the data. We understood that. Okay. It's the hard disk is again it's a mechanical device. There will be a delay in storing and retrieving the data. So they want to avoid it. So that's the improvement over Hadoop, and that framework is known as Spark framework. The Spark framework is otherwise known as in-memory cluster computing for iterative and interactive application. So what is the meaning here is, we in Spark framework, all the intermediate outputs, okay, all the intermediate outputs will be stored only in the RAM. And final output, yes, we need a final output, and then final output will be stored in the HDFS. HDFS is again, you understand that? All are hard disk, okay. But the intermediate output can be stored in the RAM. Will it improve the processing capability of the system?
Yes, sir, definitely. The processing
Yes,
or
sir.
speed will be increased.
Absolutely, you are right. So processing speed will be increased in a multiple times. Maybe like when we have a comparison, Hadoop, I mean Spark is better, 100 times better than Hadoop in terms of this processing thing. So 100 times faster. It's good, always good, right? 100 times faster is too good. Understood? Yes, no.
Yes, sir.
Yes,
But
sir.
there is some challenges will also be there. What is the challenge with respect to RAM?
cost is more.
Expensive.
Cost-wise, it's a commodity system, sir. Cost-wise, it's okay, sir. As we are using distributed environment, we will make use of all the systems RAM. So I don't feel the cost is too high.
So the storage size is limited.
Storage size is limited, yes, agree. But on the same time, again, we are using with the distributed environment, and 100 commodity hardware, 100 systems can be connected, and then you make use of all the RAM. I don't feel that also again the challenge. But we have a very important challenge with the RAM.
Temporary.
Yes, you are absolutely right. It's a temporary storage. We call this as a temporary or it's a volatile or non-volatile?
Volatile one.
It's volatile.
Volatile. What's the meaning volatile? If that is, it will not ask us to replace the data. If the system needs anything, it will automatically replace. So there is no assurance of availability of the data at all the time. Agree? That will be the challenge. But that can be overcome. Say like if some data is not available with this RAM, which is required for the next iteration, if it's not there, no problem. Go back to the previous iteration and compute and then come back. So that kind of logic is used here. So that problem is also solved in a nice way. Are you able to understand the challenge and then how we are solving it? How the developer solved it?
So, sir, so we don't need HDFS in a Spark environment?
HDFS is required, ma'am. If you want, you are doing only with the distributed environment, HDFS is required. I'm saying the input is HDFS. We can use it HDFS. And all the intermediate output will be the RAM of all the nodes. And then final output will be in the HDFS.
Okay.
Guys, are you able to understand the challenge and how they are that will be overcome? Volatile is the problem. Okay, temporary storage. We can't ensure that the data is available all the time. If the required data is not available, no problem. Go back to the previous iteration, do the computation again, and come back. In this way, they are able to solve the challenge. Most of the times, this will not come, but even it comes, it can be solved like this. So now, this kind of framework is known as in-memory computation. In-memory computation. Is there any doubt till now?
No, sir.
Yeah. So now we are going into that Spark shell. The Spark shell is otherwise known as Ripple, where we will be able to read the data, evaluate, print, and loop. Everything can be we can do it in the same shell, or otherwise known as this will be known as interactive shell. It looks like your IPython notebook. So many of you may use it. It's an interactive shell. We can integrate even IPython into use that Spark code. Okay. After some time, I will show you. All of you can work on it. Not after some time, now. Okay. So now we will start with the very basic program in Spark framework. To do this, I request all of hope madam send you a IPython notebook. Can you open that IPython notebook in Colab? Is it okay? Are you there? Can you open that document? Have you received the document? I mean, IPython notebook? Hello? Can you open it in a Google Colab?
Yes, sir. We received. Yes, sir. We are opening.
Okay.
So how do we open this, sir?
Okay, I will let you know. Go to Google Chrome or any browser, and if you are using Google Meet, you will have a Google account, so no problem at all. Go to Google Colab. Okay, get into that and open that link, and here it goes, upload. Okay, here upload and choose the file. Wherever the file will be, you can just choose it. You will get into this window. Something like here you can find Spark ML recommendation ALS, then the code, everything will be there. Are you getting that this IPython notebook there?
Yes, sir. Going to open, sir.
Yeah, please.
Thank you, sir.
Yeah, all the others, can you please confirm about at least 2 to 3 of you can confirm it so that I will be able to understand.
Yes, sir.
Are you able to use it? Yeah.
Participants, please use chat box.
No, ma'am, please. No chat box, please. I want interaction.
Oh, interact. Okay, sir.
Yeah.
Kindly
Please.
Kindly unmute your audio and speak. Interact with the speaker.
Immediately mute. That's also very important. Is it okay? Shall we?
Yes, sir.
Okay. So now in the first shell, what we are doing is we are installing OpenJDK for Java for some requirement, the Hadoop and Hadoop requires Java. And here actually we are installing Spark in Google Colab. It's very simple to use, and you will enjoy when you are able to understand the logic. You are just downloading it and then extracting it and then installing it. Okay. So just here there will be a play button. If you click on it, everything will be done for you, and you will get some command, the processing, what is processing, all these things you will be able to see here, and you can move forward. Are you able to do that? Kindly ensure that you are having 3.1.2. Recently they updated, I forgot whether I updated the notebook or not. Ensure that you are using 3.1.2.
It is 3.1.2.
Okay, very good. So,
sir, are you using Java, right?
Everything will be installed in Google Colab, sir. Java is the very basic requirement. We will not use it, sir.
My doubt is, can we use it in Python or any other languages?
Meaning, I could not understand what you are saying. So, are you asking me if the Spark can be used in Java?
No. Can we use Python instead of Java, like that, as a programming language?
We will use only Python, sir. Here we will use only Python.
Okay.
We will use Python only. Python based for Spark only. We will not use Java. Java is the one of the requirements to install Hadoop based Spark.
Okay.
Okay. Yeah. It's a basic requirement, but we will not use the Java program. Rather than we will use Python program As you know, it's a very interactive and then simple to use.
We can use other programming languages also, no, sir?
We can use it, sir. Yes, we can use Ruby, Scala, R. These are the options we have. Other than that, we can use. If you are familiar with lazy programming, yes, you can use any programming here. Shall we go ahead? Are you able to install?
Yes, sir.
Yes, sir. Proceed.
Done, sir.
Yeah, done. Then, yeah, very good. So now you will go. This may not be there with you, or just update one. You can update it. Then here the third line we are having Java Home and Spark Home. Okay, we already just installed Java, right? Java and Spark. We want to have some home folder to have all the required information in the same folder. Then here what we are doing. Can anyone say Python? Everyone many of you may know about Python, right? Can you tell me what is this? What you are doing here?
List creation.
List.
About 5 elements are created in a list called and variable called data. Okay. Now what we are saying is install PySpark. So what we are saying is just now about some professor is asking or student is asked about, is it possible for me to use other programming language or something like that? So here what we are doing is we want to use Python as the base, and we are saying like I will do some Python code and execute those Python code in a Spark environment. Some kind of interaction will happen, or APIs are there that will help us to convert our Python based programs into execute in a Spark text. To do this, we are saying like install PySpark. It is nothing but it's a Python Spark. Okay, Spark in Python based Spark. Okay, that we are installing it here. Then here, as always, there will be a object. We need an object to do all the activity for us. So here we are creating Spark context. The Spark context is nothing but object for your Spark program. If it's already there, it will be. Otherwise, it will create. And here after we will use this SC or Spark context for all our activity. Okay, that will be the entry point. You know that object. You know the concept of object and all those things. So now what we are doing it here is we are giving one more variable called just data, and here we are saying like SC, that for context dot parallelize data. What is that, my data?
Numbers.
Some numbers 1, 2, 3, 4, 5, right? So here if you do like this, this will be known as RDD, Resilient Distributed Data Set. I will come back to this in a little later stage. But as of now, you have to remember that data is equal to 1, 2, 3, 4, 5. We gave that. Then here we parallelize the data by using that Spark context. And here this will help us. This data dot collect this something like print. Okay, it will print the output. So here we are not doing any process. We just read the data and assign to some other variable which parallelize. Here what is parallelize and all the other stuff in a coming slide I will let you know. And here we are just printing it and we are able to see the output. Is it okay? Are you able to understand up to this?
Yes, sir.
Yeah. Shall I wait here for some time, or are you all the guys are able to do that? And I need another 2 confirmations from 2 different persons.
Yes, sir. Yes.
Yeah. Then I can. One more.
Yes, sir. Yes, sir.
Very good. So now what we did is we initially we feed some data 1, 2, 3, 4, 5, and we parallelize the data and we assign it into district data. Then we use collect as the function. This will be it looks like a print function. It will throw the output to us. Something like that. We can try all these things. It's available in the notebook. I will come back to that notebook little later. Now, what we want to do is we want to understand. We understood that there is a framework which is known as big data framework. If you have storage and processing, then we can call that as a big data framework. Okay, that's fine. Then we started with Hadoop. There are two components, HFS and MapReduce programming. HFS is used for storage and MapReduce is for programming. Then we come to Spark framework, where it avoids some intermediate storage in the hard disk. To avoid that, we use RAM. So it will be called as in-memory cluster computing. And now onwards, we will see what is Spark and how it works and what are the other components. Okay. Is there any doubt till now?
No, sir.
No, sir.
Right. So the core concept behind Spark is RDD, otherwise known as resilient distributed data set. If you see any big data framework, the distributed thing is the very, very important concept. We want to distribute the data as well as the property. So we are using one concept called resilient distributed data set. So otherwise known as RDD. This will help us to achieve our achieve our goal. So our goal is to distribute the data and do it parallelly. Okay. To do this, we have resilient. What is the meaning of resilient? Is fault tolerant. So if there is a data loss, how to recover the data? That will be dealt by the resilient. The next one is all about distributed. Its meaning here is we want to do all the activity across the machine and the distributed environment. We want to do it in a distributed and parallel environment. So we want to do this. The next one is all about data. If you go with a distributed environment, there is a major challenges all about if the data is changing everywhere, how will I manage? So we don't want to allow the change of data for the same variable. So always we will call the data is immutable. That is default everywhere, every day, all the data will be static data. Got the point? So here all the data will be immutable data, static data. We will not change the data. It is not possible for us to work with the data. Everything is the static data. So we will take it, and if you want to process something, you have to assign another variable. I should not say variable, rather than that static variable. Okay. We call that as a variable, right? Static data. How will you say static? See? Suddenly I could not get that word. You will say something as variable. Another one is all about if you mention that this is static, how will you say?
Constant?
Yeah, constant. We should mention that everything is a constant or static data here. Okay. Now, what it will do is there are some activities should happen with this RDD. Those activities are known as transformation and action. There are two things, okay? Transformation and action. So what is the meaning of transformation is, transformation will change it will take the data and it will change the data from one format to other format. Okay. The actions are doable activity or processing activity. It will do the processing and all the stuff. Then some of the other properties of RDD are lazily evaluated and type inferred. So type inferred, if you don't want to declare any variable type, it's like Python. Automatically it will take care and it will try to understand what could be the type of the data. Okay, those things are some of the properties of RDD. Now I want to have small quiz. Are you ready, guys?
Yes, sir.
Yes, sir.
Okay.
Okay, let me go ahead. You should give me the answer, unmute, and then give me the answer quickly. Is it okay?
Okay, sir.
Shall I move? Yeah. Ready, be ready. Ready.
Ten.
10, sir.
Why you are taking this much of time?
10.
10 is the right answer, but how much time you took for this? Where is the problem? Where is the challenge? What we did?
Went through the intermediate steps. of the calculation.
Why you?
Instead of
Yes.
looking
Why?
at the last one.
Why you did all these intermittent steps? Who asked you to do this?
Sequential processing.
Sequential processing. We are doing sequential processing. The same way all the programming languages are doing like this. It will not see where is the requirement. It will do all the activity and it will do all the computation. Finally, those kind of computation is not at all useful. Are you able to understand the real challenge of the system, our programming languages? These programming languages are not followed. So sequentially, as we did, the programming language will also do it sequentially. It will start from the first. But nowadays, we have lazy programming. That programming will create the DAG, directed acyclic graph, of required computation alone. So now, generally, it is all the programming languages will come, the traditional programming language will come from top to bottom, where it's a sequentially it will try to execute. But nowadays, we are going with bottom to top, otherwise known as lazily evaluated. So what it will do is, it will try to understand what is the required thing. So what is the required thing here? Print A. So I want only the value of A, correct? I will go to the previous step. I am able to find A equal to 10. My job is done. Nothing is required. All these things are waste. Able to understand what I am talking?
Yes, sir.
Yes,
This
sir.
will be, this concept is known as lazy programming, lazily evaluated. Lazy is good sometimes, not always. Here in the programming language, lazy is good. Here it will try to understand what is the required thing. Based on that, it will try to compute it. Okay. So now we are seeing with respect to RDD. RDD means it's combination of three things: resilient, distributed data set. So we want to recover how to recover the data is because as we are using RAM, we want to understand how to recover the data. Second one is all about we are using it's a Spark framework, it's a big data framework. We want to understand how to do the computation in a parallel distributed environment. And third one is all about if you go with the parallel distributed environment, the data should be a static one. So how to do this? So always the programming automatically it will decide and automatically fix as each and every data is immutable. Are you able to understand? Then some of the other thing is type infer and lazy programming. It follows lazy programming. So what is the meaning of lazy programming is wherever and whenever there is a requirement, then only the computation will happen. There is no allocation of memory, there is no computation, nothing will happen until otherwise there is a requirement. Is it gives some meaning? Is it understandable for us?
Yes, sir.
Yes.
So if you go with the RDD, there are two operations. One is transformation, another one is parallel, otherwise known as action. Transformations are it will convert the data from one format to other format. Okay, and there are some parallel actions, parallel operations. Those are known as action, and based on these action alone, all the transformation will happen. Meaning here is even though if your programming consists of a lot of transformation, nothing will happen until otherwise there is a action associated with that. Okay, if it sees any action, then according to that all the transformation will happen and you will get the final output. Okay, so that we call that as lineage. So lineage means it will follow some steps needs to be there. Okay, initially it will say, sorry, yeah. So it will follow the lineage thing. So if it will start with A, for example, A, then if you want to compute A, it will compute A, then it will go with B, then it will go with C. Okay, to compute C, I need B value, right? If the B value is not available in the RAM, but if you store it, it is fine. If you are not, if you say B is the intermediate value and we are giving some input will be stored in the hard disk, no problem. It will be there, permanent one. And we are doing some activity and finally we want C as the output. It's the output, but it requires intermediate output, something like B. If it's not there, it will go back to the previous step. It will try to understand the data and it will do the transformation and it will come here. Okay, then finally the output will be the process will be happening. So it will follow. We call this concept as lineage concept. So till now what we saw is we started with RDD. What is RDD is we saw. Then that how it maintains the consistency we saw by it maintains the consistency based on by using immutable concept. And all the other concept is very you could understand it. Okay. Now we will start with some of the action. Collect this some action. Initially I said we can collect the data. Then we have some take, top, first, count, reduce. All these things are there. Now I will go back to our IPython notebook to see all the outputs. So now I recollect one more time. Now you have data. So data we have 1, 2, 3, 4, 5 is the number. Then we parallelize the data. Here only we are creating RDD. So what we are doing here now, are you able to understand what is collect? It's the action. Based on this action, all the other transformation will happen. What will happen? Now just we are throwing the output. Are you able to understand up to this? So what will happen is this data at top 2.
Maximum name.
Sorry? Top 2 element will be?
Top 2 elements.
Top 2 element. Okay. Next one is all about take of 3. First 3 elements will be shown to you. Then what is the first element? Are you able to understand all these things?
Yes, sir.
Yes.
So now count. How many elements are there in the thing? 5 elements.
5.
Okay. All these things are very simple to understand. Now we are going with one more concept called lambda operation, which is known as functional programming. Have you heard about functional programming?
Anonymous function.
Yes, sir. Yes, sir.
Monish?
Yes, sir.
Yes. So, yeah, some of you may know about it, and few of you may be new to this. Here we are using lambda operation, and we call this as a functional programming. So, in general, what will you do in the function? You will say for loop for this to this much, then do some activity, then you will return the value. Okay. So all these things will be taken care in a lambda operation. Whatever the function you are giving it here, it will try to do that activity as a function across all the elements. So you could remember that we here in dist data, what we have in a dist data?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5 is our data. Yes. Now we are defining lambda function x comma y. If you have 2 elements, add those 2 elements. We are giving that as the input to the function. Now what we will do? It will take the first 2 elements as x and y, and it will add those 2 values. It will get the value of 3. Then 3 will become x, and y will become the next element. The green color are showing our elements. 1, 2, 3, 4, 5 are elements, right? Now the output of the first statement will become x, and the next will be y. Next input will become y, and the output will be 6. Then something like that it will work, and you will get 15 as the output. So to do this activity, if I ask you to write a C program, how many lines of code you need?
10 to 15, I think.
7 to 8 lines of code is required, right? Sorry, ma'am. Yeah, approximately 5 to 6 lines of code is required, right? For loop, and then the braces, open brace, close brace, in between you will assign one sum equal to 0 or I, something like that, then I equal to I plus 1. Those, all these points will come, right? But here, in that one single line, we are able to do that. Yes. So here, it is known as lambda functional programming. Here I am using it for reduce function. So here the reduce is nothing but it will try to reduce the values, and all the values will be added together, and you will get the final outcome. So now we will see with some transformation. So here the transformation is nothing but here now what we are doing is we are assigning one more variable, mapped data. What will be there in the discrete data? 1, 2, 3, 4, 5. Correct?
Yes.
Now, what we are saying as a function, what we are saying, asking him to do?
Take the square of every number.
Yes. So just we will try to square of every number and we are collecting the data. Is it okay now? Are you able to understand what is the map function? Now we are transforming the data. What is the original data will be 1, 2, 3, 4, 5. And now we are transforming the data, or we are mapping the data into some other format. What is the format is? We want to square it, square of those numbers. So 1 to 1, 4, 9, 16, 25 will be the output. Is it okay?
Yes, sir.
Yes,
What will
sir.
happen in the filter?
All the even numbers.
Even.
All the even numbers. So just a simple logic to do that, right? Now there is one more transformation is known as flat map. So flat map will, here you can see the difference between map and flat map. Map will work for every element, and flat map will work for all the elements together. Okay, and all the output will be together. That's the only difference. The flat map is mostly used in text data, and map will be used in numerical and other data. Okay. Right. Now we will go with the map reduce kind of concept. Now, can you tell me what we are doing in the first line?
Key value pairs are parallelized. After that, we are collecting the keys.
Correct. So now we are sending some input to the system. Say like apple, 1 orange, and here we have some format called key value pair. Some character, some words are given that will become a key, and numerical number will become a value. We are giving this as the input and parallelize the data. Then we want only the key from the data. So what will come as the output? If you use this m.collect, you will get apple, orange, and apple, orange, and apple as the key. Is it okay? And if I use values, what will be coming as the values?
Key values, index values.
Index values. I mean, we should not call this as index value. It will be known. We will call that as a value, key value pair. Okay, it's the value associated with our input. So we will get 1, 2, 5 as the output. Right now, can you tell me what is happening here? We saw word code program in our Hadoop exam, right? Some two different sentences are given, and then I asked you to, I gave you the how that works. Now, can anyone tell me what is happening here?
Sir, in this particular task, we are collecting in map phase. We are distributing the lines by word, and in reduce phase we are. Let me answer reduce as well. But in map we are distributing the words with a particular key as one.
Yes.
So it is
so
actually word count program.
Yes, word count program. Yeah. Tell me how it will work. You can take the input as hello VAT, hi VAT, welcome VAT, and tell me how map will work and how reduce by key will work. A small difference, okay? Reduce, initially we saw about reduce, but here we have reduce by key. That's the only difference.
In the last line, reduce by key means keys are counted. A, B is equal to A plus B. All the keys are counted, so we'll get 1, 2, 3, 4, 5, 6 we'll get.
1, 2, no, sir.
3, 4, 5, 6.
Let me go with the first step, one by one. Okay. What will happen here? Okay, before that, what will happen here? This will be the input, right?
Separate words.
Yes.
Yeah. Here, what will happen in the second line?
Separating the words.
Sentence will be separated by words. Hello, based on the space, it will divide. Very good. What will happen here?
Sir, what does
counting the words?
Single
No. Go step by step. What will happen in map?
Keys for every word.
Sir, it
Map
will
is the
put one in front of every word.
not in front, after the every word.
After, yes.
every.
Hello, 1. V80, 1. Hi, 1. V80, 1. Welcome, 1. V80, 1 is the output of this. So what will happen now? Reduce by key. What is the meaning of reduce?
Extract only
Will
keys.
add.
Not extract. We will add all the keys.
Add
Yes, all the values. We will add all the values. But here we are mentioning like reduce by key. So what will happen? It will try to understand with each key and it will do that. For example, if you take V80, V80 is a key and it is occurred with 3 times. Correct?
Yes,
1
1 plus
and
1
1
plus 1.
and 1. 1, 1, 1 is the input actually for this.
Yes.
From the map itself. Now the reduce, what will happen? Based on it will try to understand from the key and all the values will be added. So you will get the output as V80 and 3. Got it?
Yes.
Yes, sir.
Yes. Now shall we try that in our code?
Yes, sir.
So we initially I said about reduce. You know that reduce will add all the values and it will give the answer. 1, 2, 3, 4, 5 is my input in my this data. Now all the data is added and then 15 is output. Then here we are going with the map x and the x index, and you can see it's a double the values of that. Okay. Then here we are sending keys alone. All those things are already saw, right? Just I am executing it. You can see that. Yeah, this is what I'm talking. So here you see hello 1, V83, hi 1, welcome 1. As all the other words are occurred only 1 time, but V80 alone is occurred 3 times. Is it okay?
Yes, sir. It's clear.
Is there any doubt till now?
No, sir.
What does that parallelize function doing? Is it giving each word to every node, or what?
It won't give each word to every node, ma'am. Actually, if you feel that in a very if the data is very big, but as of now, we are using only one node and then we are doing it parallel. Yeah, what is parallel? The data will be spread across multiple nodes. So it will create something like a replica to the system wherever the required and activity will happen there. You know, this will be a distributed environment. Always here we are doing it in everything in a single node, but it's actually in a real time. If you do it in a real implementation, it can be a distributed framework. Whenever you store the data will be stored in a distributed system. Execution will be a distributed manner. So parallel, what the parallel will do is it will create the RDD. So Spark RDD property will come into existence. Recovery, distributed and immutable property will come to the test. So because of that, we are each and every time we are using different variable to deal with the data. That's the point. Every time we are using different variable to deal the data. Otherwise, you can't. For that only I am saying like it's immutable. We can't use the same variable again and again to do all the activities. It will not change the data. That's the way we call that as the immutable. Okay. Yeah. Is there any doubt? If no, we will move to the next part of my presentation. So here till now we saw about what is big data analytics and big data framework, and we saw how to use the Spark framework. Now my flow will be what is machine learning algorithm, and I will for a few minutes I will discuss you with this about what is machine learning algorithm. Then I will directly go into one of the machine learning algorithms known as recommendation system. Maybe new to many of you. Yeah. So what is machine learning algorithm is all about? We will involve some set of process to process the data. The meaning of processing the data here is we want to make our system intelligent. Okay, we want to make our system intelligent. It's a meaning with this is all about We want our machines to learn from the data and understand from the data and react to the data if for the new real-time case. For that, we generally we will have we have some types of analytics: supervised learning, unsupervised learning, and then reinforcement learning, and all that stuff. If we go with the supervised learning, we will go with labeled data. The data set will consist of label. Okay, we will feed that data. Initially, we will do some pre-processing. We will divide the data into training, testing. Then we will use some learning algorithm. Here, the learning algorithm is nothing but machine learning algorithm. What it will do is it will try to learn from the data. Then it will create a model, and you will evaluate whether your model is working properly or not. If your model is okay, we will go with the real-time prediction. Okay. Otherwise, we will go back to all the steps again and again and again to tune your learning. We want to make the system learn better. Okay. Always we are also doing the same way. Initial we are trying to learn from the mistakes as well as we are learning from others, and we are getting experience. We call that as the experience. The same way, the system, we expect the system should be experienced based on the data, and it should react to the new environment. Something same as intelligent person, right? So whether machines can think?
Not on their own, but
Not
we
on
can
their
make
own.
them think. But we can make them think.
You can make them to think. Very good. So this question is asked by Alan Turing. It's a very very nice researcher in computer science. He gave us Turing machine and all the other keywords kind of concepts. And in his paper in the year 1950, Computing Machinery and Intelligence paper, he writes this question, and that will be the eye opener for all the AA actually. Okay. Now, what is expected is we want to make our machine intelligent. What is the meaning of intelligent here? When it will become intelligent is if it learns from the data, if it learns from the past, it will become intelligent. Okay. So it looks like our in our movie nowadays we are seeing like AI means robots, and then Terminator, iRobot, and something like that. We are seeing like there is a human. Robo looks like a human and it do a lot of activity. It's not like that actually. So in a real time, it is not like that. So one of the case may be a robot, but in a real time, in a simple in a computer science, it's a programming language. We have to create a programming thing where the program should understand and it should learn from the data, and it should react something like it looks like a human. It should apply a human intelligence, and it may not replace the human. It will be there, and addition to that, if the human gives some intelligence or some input to the system will react in a better way. Okay. So all the other terms we know that what is that intelligence is all about? We have two different types of intelligence. One is explicitly programmed. Okay. So what is the meaning of explicitly programmed? It is with the ATM machine or washing machine. What will happen is, if you want to get the money, you will go into that and then you will feed your data and PIN number, amount required, and everything, and then you are getting the money in your hand. We can call this as explicitly programmed. Okay, already the system engineer wrote the program and everything is happening. Now assume the case. You are entering into the ATM machine or that room, and immediately it gives you the money what you are looking for. How it will be then? Assume there is a machine, ATM center, ATM machine shop, where when you enter into that place, immediately you will get the money. And the money which you required on the time when you enter. How it will be? Are you able to visualize it? Are you able to imagine it?
Yes, sir.
Sir, we don't understand the question.
You don't understand. I am not. The question is nowadays you are. If you enter into ATM machine, you have to insert the card, PIN. You should enter the PIN and then money. Everything you should do, right?
Yeah. Yes, sir.
Assume we have one more after in the coming years it will be there. There will be an ATM machine. If you enter into that particular room, ATM room or ATM center or ATM kiosk, immediately it will give the money to you, how much you expect on the time. That is, you may think like in your brain, you are thinking like I need 5,000 rupees, and you are entering into that ATM center, you immediately are getting the money without inserting the card, nothing. You are not at all doing anything. Immediately you are getting that money.
Yes, sir.
How it will be?
Emotional intelligence.
It become intelligent, right? And there is no explicit program for this. That system should learn from all your behavior, all your needs, and all it should understand about you, how much travel you did, and all the other parameters it will try to understand, and it should react on the time. Is it? Can we say that it's intelligent?
Yes, sir.
And intelligent without explicitly programmed. If you do like this, we can call that algorithm. Those things are known as machine learning algorithm. So here, what we are defining is machine learning is the algorithm which will give some intelligence without explicitly programmed. That's the meaning is the system should learn by itself based on all the other parameters, and it should react it. Okay. So there are some of few types of machine learning. One is supervised, unsupervised reinforcement. Some of you may already know about it. Just for the introduction, I am having this slide. Now, in the supervised learning, we will have a data with the label. Okay. So if you see machine learning, always data is required. Without data, you can't do anything. If there is no data, there is no business. Okay. There is no machine learning. If data is there, based on the data, we can learn something and we can react. In a supervised learning, if your data is consists of label, some defined label, then we can go with supervised learning algorithm and it will react something like this. In unsupervised, if you have a data but you don't have any label among it in the data, then we can go with unsupervised learning algorithm. Another type of learning is reinforcement learning, where it looks like a reactive function. Okay. Say if you do some activity, immediately the another action will come. Say like chessboard, white player plays, then immediately the black coin should move according to the white movement. Right? So again, the white will move according to the black coin movement. So something like that. Immediately, each and every time there is a reaction based on the actions happened in the opposite. So something like that, reinforcement learning will happen. So now. Today, for today's session, I will take you to that recommendation system. It's one of the machine learning algorithm where it has a combination of supervised as well as unsupervised learning. In general, we will use it's a supervised learning algorithm, and we will use regression function. Okay. Here. So let me introduce you what is recommendation system and how it works, and how we can implement a recommendation system algorithm using part frame. That could be the objective. Okay. So what is recommendation system is, if you buy something in most of your, not most, all of us are used Amazon or YouTube or Google. Without that, we are not here, right? And if you do something, some activity, say like if you buy something in Amazon, immediately you are getting some items, some more items that will say, hey, these are the items that are purchased together. Or this is all about all the other customers are also purchased. Did you get that kind of advertisements anywhere? Have you, are you able to recollect it?
Yes, sir. Yes, sir.
Yes. That's how they are doing it. They are using the algorithm, machine learning algorithm, which is known as recommendation system algorithm. So if you buy some item, immediately all the associated items will also be recommended to you. That will tempt you to buy. So it will increase my profit. As a businessman, it will increase the profit, and as a user, you will get a very associated product which you may like more. And here you can see the value of recommendation system. Netflix, it says like 2 or 3 movies are watched because of recommendation. Is it good, bad? 2 by 3rd.
Absolutely good, sir.
It's too good, right? 2 by 3rd is too good. And Google, they are saying like 38% of the clicks, more clicks are happened because of recommendation. And you see Amazon, 36% of sales are because of recommendation. So 1 by 3rd of their sales is because of recommendation. So you can see the value of recommendation system. Its value is too high. If this algorithm works properly, it will try to, what can I say? The user will try to tilt that user, and that user will buy so many other items also together with what they require. So what does the recommender system will do, or what is its objective is? It will try to understand about the user and items. These are the two inputs we need for any recommendation system. Then it will do some activity, and finally it will throw some kind of ordered list of what is the order list. If this will be the recommended item that will be in an order, say like top 10 item or top 15 item or top 20 item will be given as a recommendation to you. So what it will do is it will maximize our profit, or that order, the list will give us the user the temptation to buy more. So these are some of the input. User profile will be our item information, or user interaction, how they are giving the rating, tagging, and all the other information will be taken as the input. And finally, the recommended item will be the items will be the. It will try to understand what are the items to be recommended. Then it will have some list, and that will be thrown as the output. And here we have some different types of recommendation. They are content, collaborative, and hybrid. Generally, we call that as three different types: content, collaborative, and hybrid. So in content, what we will do is we will try to understand the description of user as well as profile. We will try to understand the profile of item and the profile of user. Based on them, we will try to give the recommendation. In collaborative filtering, we will try to find similar user or similar item. Okay, we will try to find similar user or similar item, and based on the similar user preference, we will give the recommendation, or similar items preference, we will give the recommendation. Okay, so this is already we saw. There are two functions generally. We will try to predict what is the rating. Then based on the rating, we will try to give the recommendation. For example, if you take a memory-based approach, what will happen is now the user did some purchase some item. This user purchased only this item. Okay, this user already purchased these two items. Now you can see this user and the first user is more or less similar. Their buying habit is same. So based on that, what will happen is as he already purchased this item will be given as the recommended item for his third user. Will it tempt him to buy something? That item?
In some cases, yes.
Not some cases. You can see that 2 by 3rd. At least 50% about one, at least minimum 1 by 3rd of users are doing like this because of this recommendation that business is improved. So what will happen? Here we will give some input. We will try to find a similar user, and we will by using nearest neighbor algorithm. And finally, we will recommend the item. Okay. But here we have some challenges. Something like calculating the similarity between one user versus other user is a very difficult task, and time complexity is very high. Okay. So to do this, they have go with clustering algorithm or dimensional reduction algorithm. Now we will go with the dimensional reduction algorithm in R-square. So what is curse of dimensionality? We have a huge number of data, but most of the data is very minimal data is only available. So the data will become a very sparse. If you have a sparse data, working with the sparse data is very difficult. So what we have to do? We have to reduce the dimension. So with the small dimension, you have to, what can I say? If you are able to get the same meaning, then we can say we can do dimension reduction to do that. Okay. But in general, if you feel huge dimension, then the data is good to know. If the data is very small in size, then only we will be able to do a lot. So always we will try to apply some dimension reduction technique to reduce the data into smaller dimension to get value out of it. Okay. So now these are the things we can just understand. In a recommendation system, here we will have customers and movies. Now it will be a very big matrix. Numerous number of customers will be there and numerous number of movies will be there. Working with this data is very difficult. Understood what I am talking here? Say like if I have 1 lakh customer and then 1 lakh movies, it will be a 1 lakh into 1 lakh data set. Is it easy to work with that data set? Will it increase the computation time?
Yes, sir.
Yes, sir.
So what we want to do, we want to reduce that matrix into small matrix. So here we have the concept called, in general, a concept called matrix factorization. What is matrix factorization is, a very big matrix is converted into 2 or 3 small matrix. That is, we know that we know the concept of matrix factorization, right? So we will divide, we will convert the data into small matrix, and if you multiply these two matrices, you will be able to get the original matrix. That is the logic behind matrix factorization. You know that. Are you able to recollect the matrix factorization concept, mathematics? So here we are just converting a very big matrix into small 2 different row matrix and column matrix. If you multiply these two, you will be able to get the original matrix. For example, if you want to get this value, you will go to that row matrix of the particular row in the column and particular column value. You multiply these two values, you will be able to get the original value. Okay. So here we have singular value decomposition. It's a one way of doing dimension reduction. You will convert the data into 3 different components actually. U matrix, V matrix, and then summation diagonal matrix. If you have that, you can use it. So in recommendation, what we will do is we will have a original data, then that data will be in a matrix. We will apply SVD algorithm. Then we will get 3 different matrices, U, V, and summation. If you want any recommendation, you will be able to multiply all these 3 values, and you will get the final answer. For example, this is all about my input. Okay, that input is now divided into 3 different matrices. And for if you want any value, say like this value, you have to go to this one and the 12.4 and 1, 2, 3, 4, right? 4, 1, 2, 3, 4. So this value, if you multiply these 3 values, you will get approximately 5. So something like that. The original matrix is something what you have, and the reconstruction with the missing error will be this much. You can see if you are able to achieve the original. If you convert this, you can have only a small 3 matrix of size. Here it's what is the size of this matrix? Can you give me the size? How will you represent this matrix? 5 by
7.
5 by 7. But here you can have, even this value is very small in number, you can remove it. You can have 5 into 2, or 2 into 5, or 5 into 2. You can remove this. Now, if I have this small matrix, if I want any value, I have to go with, say like the first value, I will go here, all the value multiplied by 12.4 multiplied by this value, right? If I multiply all these things, will I get the first value? This is just a matrix multiplication. Are you able to recollect it? Matrix multiplication, factorization?
Yes, sir.
Okay. So something like that, we have another algorithm called ALS, it's alternating least square algorithm. We will have 2 different matrices, and then we will be able to do that. Okay. So these are some of the publications what I have with this recommendation system. If you want, you can go and refer this paper. If you want to discuss with me on this paper or any other concept in recommendation system or anything, I welcome you to discuss with me. My session is over. Now we will go back to that Spark shell, where here you can find that algorithm, how to use that algorithm. Okay. So here we are reading the data, and we are having 3 different components in the data. If you just print the data, you will be able to understand. Here we have 3 components. One is all about rating. Okay. So you can just execute it, and here we are using ALS algorithm. So for ALS, you have to give 3 inputs: rating, rank, and number of iterations. You should give us the input. Then you can send some new data to predict it. Okay. So here you can see the input will be like this. 115 means user number 1 for item number 1. User number 1, item number 1 is giving rating as 5. Got the point what I'm talking? Hello guys, are you there?
Yes, sir.
Yes,
User
sir.
number
Yes,
one
sir.
for product
Yes.
number one is giving rating as 5. Now we have applied our ALS algorithm in or you can apply even SVD algorithm. You will get a matrix. Then for any test data, if you give that test data, it will try to predict it. So we are giving again the same data as the input data, and now we are going with the prediction. And here for prediction, what it says is 4 for movie user number 4 for movie number 4 he gave something, but the prediction is something like 4.99. Let me see what is the prediction and original rating. Okay, for user number 1 for movie number 1, the original rating is given by the user is 5. But what about our prediction?
4.99.
4.99. Is it good or bad?
Sir, it is close, so it is good, no, sir?
Which is good, right? So something like that. Here we are here we are giving our training as the input, and we are applying our matrix factorization. Then for test data, we are able to predict it, and we are just understand that yes, we are able to predict the rating perfectly. But if you do like this, we can say these are some of the recommended items. Are you able to understand this logic?
Yes, sir.
And other than that, I gave classification algorithm, naive-based algorithm, how to implement naive-based algorithm here, and clustering algorithm in the coming slides. You can just execute it and then you can understand it. So that's all about my session. If you have any query, you can ask. Sorry, I took about another 9 minutes of time, your time. The time given till 11, but 9 minutes is extra now.
Thank
If
you,
you have
sir.
any doubt, you can ask.
Thank you, sir, for the informative, illustrative presentation. It's time for question answer session. Participants, if you have any queries, please post it in the chat box, or else mute your audio and ask your questions.
Sorry, I wrongly. Hello, are you able to hear me?
Yes, sir.
Yes, sir.
Yeah, I just wrongly posted that window. I did my session. If you have any query, you can ask me.
Sir, there is a query from Rahul Bhupati.
Okay.
Sir, how can I use Hadoop in Industry 4.0?
Industry 4.0, Hadoop and without MapReduce and Hadoop, there is no Industry 4.0. All these will be known as Industry 4.0. Without all this machine learning algorithm and automation, there is no Industry 4.0.
Okay,
should we go to that chat box and read and do, or where can I get those questions?
At the bottom of the chat box, sir.
No idea. Okay.
The next question from Lakshmi Agarwal: how to choose 3 matrix size in SVD?
We don't want to choose 3 or 4. Actually, if you apply SVD, it will give us all the matrix, and we have to see whether that how many column can contribute and so based on that we can choose. So if you see in our example, the third one values are actually, if you see value, very negligible value. Am I sharing my window? Yeah, if you see this, here the values are actually negligible. 1.3 is the negligible. The summation is 1.3. It's the negligible compared with 12.4 and 9.5. So I can say that this matrix can be converted into 2 cross 7, 2 cross 2, and 7 cross. Am I answering your question?
Yes, sir. Okay, sir. There is another question from Manchulada Reddy. What are the different reinforcement algorithms?
We have many. Q learning is the one type. It's a very different field, ma'am. I'm not that much confident enough in reinforcement. I'm not focusing on it.
Okay, sir.
So may I ask
Ma'am,
one question?
actually, if the audience asks the question, it will be great. I can understand what sense they are asking, and then I can reply. I don't want to see the chat box now. Can you please ask the participants to ask questions?
Sir?
Yeah, sure, sir.
Yeah, Monica, ma'am, yes, please.
Sir, I was trying to make one recommender system that you must know about, that BX book recommender system, that data set, BX book crossing data set. So I
Okay.
was doing that in normal Jupyter notebook. There I got error for that memory storage it is not capable to store all the data after
Yeah, yeah, yeah.
making that matrix or rating matrix. So after that, I stuck there. So is it possible to do that in this environment, like a Spark environment? Whether
Yeah, before going into Spark environment, you can even just use with the Google Colab. The same IPython notebook can be loaded into Google Colab, and then you can execute. Environment will be bigger than your laptop.
okay.
If not, you can go with all the others.
Okay. So does this Spark help me for anything for that, sir? Where this
Definitely,
Spark
it will
help
help,
me?
ma'am. Yeah, definitely, it will help. And in our research, we identified that it's even 100% faster than Hadoop. Okay, and we feel that the time complexity is highly reduced when we go with Spark framework.
Okay.
Okay. So I feel it. You know that matrix factorization is the too complex task to do that. Okay, SVD, ALS, all these things are very complex things. And if you have a very big matrix in 20 million, so generally in a benchmark data set we have 20 million. So 20 million users are there, and doing all the computation is very difficult. And after that we go into that Spark framework and we enjoy it with the output. And it's very quick to implement and then easy to implement. It looks like a Python code, right? It's a very simple 5-6 line of code, and then within this 1 hour, if you are able to understand, then what's the problem? If you go and spend little time, yeah, you can learn.
Okay. Sir, is there any resource to learn the Spark in a better way for that recommender system design only?
Ma'am, here you can have a Spark documentation. I will throw it in our chat box. You can just go and see that nice information is given there. Okay. I'm sending that into our chat box. You can see. Yeah.
Thank you so much, sir.
Yes, sir.
Sir, shall I ask the next question, sir?
Please, ma'am. Please.
Yes, sir. Can we create chat box using reinforcement learning?
Yes, that is happening in all our chat box applications. Here, whenever you in most of the websites nowadays they have chatbot, right? It's created by using reinforcement as well as very basic machine learning algorithm. Easy to create.
Okay, sir. Thank you. And another question from the same person. Is Spark open source?
Yes. Open source available. The link is also shared. You can just go and you can see the same documentation link. You can see the code and then you can modify the code. Easy to implement. Easy to what can I say? Easy to install it in a multiple nodes. Very simple to use.
Okay, sir. A question from Mona. Ms. Mona, how can a fresher start working on big data who is completely belong to different field?
Sure. How to answer? The same way how you are learning for anything. You have to spend some time, that's all. Nothing else. Even I'm from in a Tamil medium school, government school, did everything in a Tamil medium. After that, the environment makes me to learn. Okay. Be in an environment where you can learn. Just, I can say like that, that's all. If you feel that you need, yeah, you can learn. I don't see like it's something special is required.
Good morning, sir. So will you please give some suggestions? How can I start working on big data initially?
Do a project. Mona, from where and what you are doing?
Sir, I have completed MTech in Power Electronics and Drives.
It's very nice then. Then actually, why don't you think about power electronic drives, we have a lot of data. Now the data is say like in a power grid, huge data is generated in each and every second. Okay. Now how to process the data? If you feel like that, and if you think that, is it possible for me to use big data analytics for this data? Yes, you can. You will be able to do that. That's a very simple idea. Will be try to understand the fundamental. About last 1 hour, I gave you the fundamental. This is not enough. You have to go and do practical things. Understand how to feed the data and how to do that. Very simple analytics. Then go directly with your data.
Okay, sir.
Got it?
Okay,
So
thank you,
data,
sir.
your data will also be the same way, right? It will be having some numerical data, and then finally it will say power drift or not. Then it will become a label data. Otherwise, you can go with the clustering algorithm. How do you say that?
Yes, sir.
Small understanding is required. You can do that.
Okay, thank you, sir.
Thank you.
A question from Mr. Danveer Ahmed. Can we use any other dimensionality reduction method like PCA?
Yeah, PCA, we can use it, but PCA, the challenge of PCA is it's not a distributed one. It's very difficult for us to distribute it. Okay, so and the way how we apply PCA is different, and ALS and SVD are highly useful for matrix. If the data is in the input data is the matrix format, and application wise it's different. PCA is also one of the dimensional reduction methods can be used in other fields, but not too much in our recommendation system because of data and nature of the data.
Sir, can we use Spark is in real-time data processing?
Yes, we have a concept of streaming analytics in Spark framework. We can use it.
Okay,
streaming Spark.
Streaming Spark. Okay.
Yeah, you can note it down and then you can see some references are available. Streaming is completely different. So in streaming, you have to before storing the data, you should analyze, right? So that component is also available in Spark. We call that Spark streaming. Okay, you can just go and understand what is Spark streaming. One ML trainer is there. Hello, sir.
Hello, Professor.
Yes,
hello.
Please.
Hi, glad to meet you as well. Thank you. I'm the next speaker, so I joined a little early.
Okay.
Welcome,
Sorry,
sir.
I eat your time.
Welcome, Sunil, sir.
Yeah, thank you, madam. Thank you so much.
Thank you, Science, sir.
Yeah, now I think I have to go as the next speaker.
Sir, you just sharing. Sorry, sir. Science, sir. Please share
yes,
your
please.
mail ID, sir, so that the participants, if they have questions to ask, they will just post it. Share your.
I already shared that PPT,
you
know, in that my mobile number and email ID is there. If they want, they can interact.
Yes, sir. Thank you,
yeah,
sir.
Thank you all. Thank you all.
Thank you, Syed sir, for patiently answering all the questions raised by the participants.
Thank you. Thank you. Bye.
May I now invite Ms. J. R.O.K. Mary, Assistant Professor of Computer Science, to propose the vote of thanks. Please, ma'am.
Good morning to everyone. Oh, come, let us sing to the Lord. Let us make a joyful noise to the rock of our salvation. Let us come into his presence with thanksgiving, for the Lord is a great God and a great King above all gods. Psalm 95 verses 1 and 2. I take this moment as a great opportunity to say a word of thanks to everyone on behalf of the PG Department of Computer Science, Holy Cross College, Trichy. I thank the Lord Almighty for his constant blessings throughout the entire session. I warmly thank Dr. S.P. Syed Ibrahim, Assistant Director, International Relations, Professor, Grade 2, School of Computer Science and Engineering, VIT University, Chennai, for his wonderful presentation on Machine Learning in Big Data Framework. I am thankful to you, sir, for sharing your academic knowledge, expertise, and intellect with us, and providing an insight into the concept. The session was indeed very useful and interactive. Thank you, sir. My sincere thanks to all the participants for their active participation. Once again, I thank each and everyone. Thank you.
Thank you, Mary Madam. Dear participants, let's have a short break. The next session will start shortly. Dr. Roslyn, ma'am, please mention the timing of the next session, ma'am.
Yes, ma. Yes, ma. Participants, can we continue the next session or do you need any break? The next presenter is available with us. He is already in our meet.
No, madam, it's fine. I mean, I'm sure they will be very exhausted after a hour of presentation, right? It's
Yes,
okay to
sir.
take it's okay to
Okay.
take like 5-10 minutes break. I'm fine
Okay.
with that.
Thank you, sir. Thank you, sir. So participants, you can just go out for 10 minutes. Please come and join for the next session sharply by 11:30. 11:30, sharply 11:30, next session starts. So please be connect yourself with us by 11:30. Thank you.
Thank you, ma'am.
Madam, please let me know when we can start. It's 11:30, right? So whenever you guys are ready, I am ready too. I hope you're able to hear me loud and clear. Madam, am I audible?
Yes, sir. Yes. Sir, shall we wait for 4 more minutes?
Yeah, I'm fine with it. No issues. Thank you.
Yes, sir. Thank you, sir.
Sir, you present your screen. We can check that also, sir.
Is my screen visible, madam? Madam, is my screen visible?
Yes, Sundar. Welcome.
Cool. All right, cool. Thank you, madam. Good to see all of you.
It's going to be 11:30. Shall we start? Edel?
Yes, ma'am.
Are you
Shall
ready?
start, ma'am? Yes, ma'am.
Yes,
I'm
sir.
ready.
We'll
I'm
start.
ready.
We'll
Yes,
start.
ma'am. Thank you, ma'am. Welcome back to the second session of the day. May I now invite Ms. M. Baby Nirmala, Assistant Professor of Computer Science, to welcome and introduce the resource person. Please, ma'am.
Welcome to those who believe in the power of trees and who would like to join me in my exploration of life, says Bernard Picard. It's my privilege and honor to introduce you one such eminent personality who believes in his dreams. Dr. Sunil Chingamgadi is an avid coder, passionate teacher, lifelong researcher, technical writer, and an admirable speaker. He works as an engineering director and head of data science, innovation, and digital automation with us Technology Center Bangalore. He is responsible for AI research, open innovation, and data products development spanning across worldwide. He plays a key role in helping the business teams identify the right opportunities, working with the ecosystem, partners, and technology teams to propel innovation further. Dr. Sunil is an adjunct professor teaching courses as a part of MTech, PGPIML, PGPIFL in Great Learning, and PGDM in Crescent University. Dr. Sunil has PhD in computer science, specialized in machine learning and natural language processing. He is conferred with prestigious 40 under 40 Data Scientist in India award for the year 2020 by Analytics India magazine. He is also honored with the most coveted Makes Innovator Award to 2020. He is an AI researcher with 18 plus years of industrial experience. Prior to joining Mesa, he was an AI Center of Excellence at Fidelity Investments, Pico, APT, Mu Sigma, etc. He has published several research papers in Scopus, IEEE journals, and is a regular speaker at various research and conferences. He also has 2 books published by Packet Publishers, UK, namely Or Machine Learning Projects and Advanced Machine Learning with R. Dr. Sunil has filed 6 patents in the last year, and 1 patent got issued from USPTO. He has won multiple hackathons. Gary Kilpatrick says, if you want your dreams come true, you have got to chase them down and it comes to you. I knew him as a person of hard work who strives hard to climb the pinnacle of success with endurance. I still remember the aspirations he shared when I met him first time in 2014. Thank you, Dr. Sunil, for accepting our invitation even among your busy schedule. I am happy to invite Dr. Sunil to share his profound knowledge with us. Welcome.
Thank you, ma'am, for the
Thank
warm words of welcome. May I now request Dr. Sunil Kumar, Engineering Director, Head of Data Science, Innovation and Digital Automation, MERS Technology Center, Bangalore, to take over the session. Please, sir.
Right, thank you, Ms. Edel and Professor Nirmala. Thank you so much for the warm welcome and for also having me here in the session. So this is going to be a very practical session. I'm going to be teaching you a lot of tools today. So I'm not a big fan of PPTs and stuff. So I'm going to use the traditional approach of, writing things on a notepad. So let's see how it works. I want to make sure that you guys um, get a hang of what I'm going to speak. So I'm not a big fan of reading from PPTs and stuff. So rather I would demonstrate what each of the tool does, etc. So let's have it as an interactive session rather than me speaking all the time and lecturing. So if you have any questions in between, feel free to raise your hand and we might pass on the chance to you so you could ask the question. Right. So, what is the purpose of machine learning model, right? As I'm assuming most of you are from academics or working in various colleges and stuff. See, for you, machine learning is more for your research and to kind of bring out a project at your place. Generally, the project is developed in a IDE such as Jupyter Notebook, right? So Jupyter Notebook looks like this. Anaconda Python is the most famous Jupyter tool, or we also have Spider and.
Sir, sorry for the interruption, sir. Kindly switch on your video also, sir. Video as well as your presentation. Switch on your video and then present.
Madam, I think there would be some problems with the bandwidth, so that's the reason I'm not turning on the camera. I can turn it on and off, right? Because people need to listen, right? So I don't want the voice to break in between.
Okay, because Atel asked us to take the video, both video as well as audio, and post it in the Atel portal. That's why I'm asking. No problem, sir.
Okay, sure. I mean, we'll take it on and off, right?
Okay, okay, sir. Thank you, sir.
Cool. So Jupyter Notebook is one of the tools that we use in the industry very commonly for development purposes. And I would also request everybody to go on mute because I can hear a lot of static in the background. Madam, if you could actually go on mute also, please.
Yes, sir. Sure, sir.
Thank you.
Check.
All right, so Jupyter Notebook is one of the popular tools which we use in the industry in order to develop things in Python. So this is how Jupyter Notebook looks like. And for example, if I say print welcome, you run it here, right? And then this is how you develop any data science project step by step, and then you see the results then and there in Jupyter Notebook and take it forward to production and stuff. So the key is to productionalize this machine learning model, right? The first and foremost thing that I wanted to talk about is how do you productionalize the model? Say, assume that you built a Python ML model. Now, when you develop a Python ML model, for example, this particular line called print welcome is in your RAM at the moment. So the moment I close this Jupyter Notebook or shut down my system, this is gone. So which essentially means you're back to square one. That means you will have to build your machine learning once again, or you will have to write your Python commands once again, and which is not going to be helpful, right? It's not that every time you have to predict something, you will have to build a machine learning algorithm. Say, for example, you built a very complex machine learning algorithm, a computer vision algorithm to detect cancers from the MRI scans or PET scans. It's not that every time you go ahead and train the model, right? The idea is you train your ML model once, and then you persist the model, right? See, it is similar to I have written something on my notepad, and then I'm going to go and save it, right? So how do I save my machine learning model onto the disk is the first thing we're going to touch upon, right? So basically, I'm trying to talk about how to save your model to disk and reuse it whenever you want. Madam, please, can I request you to go on mute? It's quite uh, quite a bit of background noise is there. HCCCS 2021. I'm requesting you to go on mute, please. Madam, please, can you try and go on mute?
Dr. Rosalind, ma'am?
Okay, I think she has some problem at her end. That's fine. I'm getting echo when I'm speaking, or I can hear that white noise. Okay, so that's fine. It is what it is, right? So the idea is, how do you convert the model that is on your RAM and then put it onto your disk so that you could reuse it whenever you want it, right? So this process of persisting the model onto your disk is called as pickling, right? So let me show you an example of how pickling is done. So pickling basically helps us to persist your machine learning model that you've built in a Jupyter Notebook environment or any other environment onto your disk. And whenever you wanted to reuse that particular model, you don't have to start from scratch. Yeah, you could actually go ahead and reuse it once again. By just loading the model, right? It is like I have saved this particular notepad details onto my disk, and whenever I wanted to reuse it, I will just go ahead and reopen it from my system, right? So that's the process that I'm talking about. So there is a library called Pickle in machine learning, and which is what we're going to make use. I've just built a small machine learning model on Jupyter Notebook here. What this particular notebook does is it goes ahead and reads a file which is called as square feet. So let me show you the file, how it looks like. Right, so this is the input file, which is my trading data. Right? A 150 square feet house costs $6,450. A 200 square feet house costs $7,450. A 600 square feet house costs $18,450. So I wanted to learn how much is the price of a house based on the square feet of the house. It's a simple linear regression model that I'm trying to build. I mean, the idea is to learn about how to pickle the models and how to expose the models in production. It is not to learn how to do modeling. Therefore, I picked up a very, very small model for the demonstration purposes. So you can see that there is a library called NumPy, which I have imported here. NumPy is more of a matrix operations library in Python. And you have scikit-learn, scikit-learn is more of a library where you have a lot of algorithms like linear regression, logistic regression, random forest, XGBoost, etc. All of this algorithms exist in scikit-learn library. And pandas is nothing but your data structure, right? So a table data structure is what is called as a panda in Python. A data table or anything that is in rows and columns format is what we call it as panda here in Python. And I have imported a linear model library from scikit-learn. That is where your linear regression algorithm exists. And OS library, if I wanted to change my directory or if I wanted to execute any operating system level commands, that would be done through your OS library as such, right? So that's the reason I have imported OS library. And I'm here saying that os.chdir. Chdir is a command that helps you to change the working directory in Python. So I'm just doing it. So basically, there is a default directory in which Python runs. And whereas my input file is located in this particular directory, therefore what I did is I changed my directory to this particular directory where my input directory is there. Chdir is change directory command. It's an operating system command which can be executed directly from the Python notebook, right? And what I'm doing here is I'm saying there is a file called input data in your directory. Go ahead and read that particular input file through this command called pd.read_csv. And I'm saying there is a separator between both of them, which is a semicolon. CSV is comma separated file, right? So it by default expects the two fields to be separated through a comma. However, if you look at our input file, it has semicolon as my separator. Therefore, I am separating it through, I'm saying separator is going to be a semicolon. And I'm declaring two different parameters here called X parameter and Y parameter, because scikit-learn all the libraries, say for example, I'm going to be using a library function called linear regression. And this library function takes two different parameters. One is X and one is Y. X is nothing but what you are intending to predict, which is nothing but your target, and that is Y. And your X is nothing but what are your features that will help you to predict. So in our case, square feet is our variable or feature that helps to predict the target. And I'm running a for loop here to read each of the data points from the input file and get it into X parameter. And I'm reading this particular file again to get the price values into Y parameter. So I have now X and Y, and I'm instantiating my library function here called linear regression. And I'm saying there is something called linear model, which is your library. From that linear model library, go ahead and pick up your linear regression and go ahead and fit that particular model. This is all you would do, right? I mean, this is just 2 lines code in Python, which will help you to build a machine learning model, right? At a very simple level. And I'm saying, okay, let me go ahead and pick up this particular linear regression and build the model with X and Y parameters, which is pretty easy. And now I'm going to test the model to see if it is working. So the question is, how much does a 750 square feet house cost, right? So I learned the relationship between square feet and price with that particular model, and I'm trying to now, and the model now lies in regr variable, which is in your RAM, right? And I'm making use of that RAM model, the model that exists in your RAM, and I'm going to predict on a particular square feet. Now I'm interested to learn how much does a 750 square feet house cost me through this particular model. And the moment I apply this, I'm able to see that it costs about $23,354, right? But the problem is this model called regr exists in my RAM, which essentially means the moment I close this particular notebook, it is gone forever, right? Which means you're back to square one. You have to do all this process in order to get your memory, get the model in the memory, which is not a scalable thing, right? So every time I don't want to build the model overnight. Here it is so simple because we have one variable, but it could be that there are thousands of variables in industry where you will have to rebuild the model. Takes a long time, right? So that's the reason we have some process called pickling, right? Pickling is the process of storing the machine learning model onto your disk after it is trained. That way you could reuse it whenever you wanted. Okay, so pickling is like saving a file, right? Here, this is where I wanted to save my file. So what did I do? I did import.os, os.chdir changes my directory where I wanted to save the file. And I said pickle, import pickle. Pickle is the library that has the function to save my model, right? So this is like writing a file in your C language, right? So it's just that you're writing a model content from the RAM to your file. So pickle.dump essentially does writing or saving the model contents to your file. And pickle.load basically reads the model, reads the saved model from the file to your main memory. So you could reuse it, right? So these are the only two commands. These are the only two commands you will have to remember, right? So that's exactly what I've done here also. You can see I'm changing the directory, import.pickle, and I've given a name called sunil.pras. I mean, you can give any file name and any extension. It doesn't matter. I just gave it sunil.pras as a sample, right? My file name is going to be this, and pickle.dump. And I have already created my model with a variable name called regr. That's the variable that I'm picking up, and I'm saying open this file called sunil.pras in write binary mode. And what this pickle dump does is, whatever is the content of regr, it goes ahead and puts it onto a file called sunil.pras. And the moment you execute this particular thing, a file gets created on your laptop, right? On that particular I mean, I have actually ran this particular thing before the class itself. So you can see there is a file called sunil.pras that was created. And will I be able to see this file contents? Yes, you will be able to see the file contents, but it doesn't make any sense because it's a binary file, right? You can see that it's a linear regression model, and there is nothing you will be able to really understand here because it's a binary file format. Okay, so this is how you save the model onto your disk. However, if you wanted to reuse it, right, all that you need to do is go ahead and do a pickle.load. And I'm saying, okay, using the load command in pickle library, go ahead and open this file called sunil.pras and read it in binary mode. And the model name now will be load model because that is the variable name that I've given here. Okay, so now after that, and I'm going to say that I can use this particular loaded model now to predict any square feet price. So for example, here I have passed 1050 square feet, which essentially is the square feet value for which I am interested to know the price for. So I'm applying the predict command. Automatically, the model is now able to predict, and I'm able to print the result, right? And it is saying that 1050 square feet house costs about $31,987. And is this the only way? Pickle is the only way to save the model? No, there are lots of ways to save the model. Another library that helps you to do this, and which is pretty commonly used in the industry, is joblib. Right, it's an external library, and you can use this particular thing also. Again, the commands are same: joblib.dump, joblib.save. I mean, joblib.load. These are the only two commands. There is nothing as a difference. You could use either of the libraries to do it. Say, for example, joblib I have imported here, and I'm saying This should be my name of the file where I wanted to write the file contents, regr.file name. The moment I do joblib.dump, it is going to create a file on my local drive, right, with that particular file name. So you can see finalized model joblib.save is created. Now you could use that particular file that where it has the model contents to be loaded into your main memory whenever you want. It doesn't have to be on the same notebook. For example, I could open a new thing here, new notebook here. I can say import.pickle, import pickle. I can say xyz equal to pickle.load, and I can give this particular path. Let me show you live what happens when I do this. So let's see if it happens, right? So it is saying there is some problem with this particular thing. So let's go ahead and take out pickle.load. Or we have to first open the file, right? So obviously open it in read mode. So because it's a file, right? So it is saying take that particular file, open it, and then you'll have to read it. Right? It is reading the file from that particular directory. It has read successfully. Now you can print XYZ. XYZ is a linear regression model. So I'm saying XYZ.predict. How many square feet? Say I wanted to know how much a 2000 square feet house costs. It is going to cost me $59,325. So you could see I have saved the model in a particular directory. In this fresh notebook, I was able to load the model that I have stored on my disk, and I was able to reload this, reuse this particular model whenever I wanted. Okay, so it doesn't stop here in the industry, right? So this is more about persisting persisting the contents onto the disk, right? But you cannot ship your laptop to the customer, right? You need to put it on a server, right? This loading and scoring of the model happens on a server, and the server IP is what either you have a mechanism to transfer the files from the files that need to be scored from the customer to the server, and then you score it in batch mode or real-time mode. Okay, let me give you both the instances. Let me also show you how to productionalize the model in real time as well as batch. So there are two modes in which we productionalize the model. One is called batch mode, another one is called as real-time mode. Okay, so think of this like the erstwhile NEFT, right? And think of this more like RTGS. So we wanted to transfer money to a person, and now I go ahead and initiate any NEFT transaction. What happens is all the records that need to be NEFT'd gets queued. And once every hour, this NEFT job runs, and this particular job processes all the records that are queued so far in the last 1 hour, and then makes the transfers. So this is batch mode, right? Similarly, we have real-time mode. This is more like RTGS, right? I have a web application. Say, for example, I wanted to know how much home loan am I eligible for based on my historical data. All right. So RTGS, I mean, what I do is I have a form where I fill all the data, and the moment I click on the submit button, my input data, whatever I've submitted on the form, should go ahead and hit this particular server and get me the results right away. Right. So this is real-time mode. So both this particular batch mode and real-time mode, is something which we also do in productionizing machine learning models in industrial also. Right. So at times we may have to do batch mode. At times we will have to do real-time mode. Using this pickle file, how to design a batch mode thing and how to design a real-time mode thing is what we're going to see now in the next half an hour to 1 hour. Right? So we're going to make use of something called Flask. It's a framework to make web applications in Python. We're going to make use of our Flask web application framework in Python to expose our machine learning model as an API, and we're going to see that live demo right away. Okay. So whereas batch mode is very easy to do, right? How do we do batch mode? What is the use case for this? Let's see the use case. So I want to do a marketing campaign in my organization. So I have a new product and I wanted to roll out a 20% discount on the product. Who are the eligible customers for this particular, or prospective customers for this particular discount to be rolled out? Particular discount to be rolled out. So this is the question, or this is the use case that I'm trying to solve. Right? In this case, real-time responses are not required. What will I do? I take all my customers in my database, and then maybe I will score it overnight to see which customer should be given this discount and which customer should not be given this discount. And because there is every day new customers coming up in my database, every day I will have to run this particular machine learning model in the night at a particular time. So that way I could basically score the customers and roll out this particular marketing campaign with a discount of 20%. Right? So that's the batch mode thing. Whereas real-time mode, it is more like, okay, I want to get a response right now. So for example, how much credit card, which credit card am I eligible for based on the parameters that you have input? Which course am I suitable for based on my psychometric test? I wanted to get an immediate result from the form. So so these are two design aspects, right? Either I expose my machine learning model in batch mode or real-time mode, completely up to me, right? So so think of it, what you can keep in mind is batch mode is more like NEFT. It runs at various periods of time in my day, whereas or it could be just overnight batch, or it is in real-time mode, which essentially means it is RDGS, right? It is like you put the transaction onto the bank and immediately it basically transfers the money to the recipient account, right? So the same way your model file, whatever you have pickled, is also exposed in both the ways. Batch mode is very easy. So this is again a Python script, right? I will write the pseudo code of the Python script right away. Okay, let me take the new Python. So basically what I do there is, again, import pickle, and I will say import OS. So this is the script that I would write it on my server, wherever I need to do the processing of all my records. Okay, so let's assume this is the server, or I can write it like this: server slash. No, server is nothing but the server IP and all that, right? So whatever drive you have in the server, in the C drive, I have my model pickles library, where I have put this particular pickle files, right? Basically, after pickling, you can move this particular pickle file to the server. I mean, you can FTP it or you can send it on email or anything like that. And once it is there, you basically move to the directory. So the next thing that I will have to do is obviously read that pickle file. Okay, this is how the file is. And then xyz dot score or predict. But before that, there is one thing that I'll have to do. Remember, all the records that are queued up will need to be read. So I will say records to be scored is a data frame, import pandas. And basically, I will say connect to the database and read the data into this panda. Okay, so I've read all the records now into this particular thing called this particular table called records to be scored. And this is a pseudo code that I've written. Obviously, you will have to convert that into code appropriate to your database. I mean, sometimes the queued data could be in SQL Server, sometimes it could be DB2, sometimes it could be DB400, or it could be just a file also, right? Based on that, you will have to convert this particular pseudo code into appropriate code. So now, what do I do the predict on? I do the predict on this records to be scored. Okay, and then I store the records in scored records, which is another variable. Right? It will have all the scored records, and whatever your predictions are from your machine learning model, that will be stored in scored records. And then the final thing is to write the predictions, write the scored records to the database. Or downstream processing. Right, so this is it. I mean, this is the 4 or 5 lines that you'll have to write for you to go ahead and do your batch processing. I mean, of course, I've written it in pseudocode, but I mean, when should my batch run, or when should this particular job run? How do I particularly write this particular? I mean, how do I schedule this? Right. So let's go ahead and look at it. I'm going to save this file on my server on a particular location. Say, for example, I'm going to store it here, saying that it is a Sunil model pickle run. And it's a Python file, right? So what I'm going to do is I'm going to say all files .py. Now it is recognized as a Python file. All right. So I will go to Windows Task Scheduler. Yeah, you can see Windows Task Scheduler, right? I mean, so this Windows Task Scheduler, or you could use cron job, right? So let's go to control panel. And here it is saying you will have to go to, let's go ahead and search for. Yeah, administrative tools and schedule task. So this task scheduler, you can open up and you can go ahead and schedule the task to run at any given point of time, right? Say, for example, if I have task scheduler library, go ahead and create a task. Here you can say that this task name is this, and I wanted to run it, every time a new file arrives, or I wanted to run it at a particular time of the day, etc., etc. Right? You can even say that I want this particular file to run on Saturday and Sunday only, and not on other weekdays. All of this task scheduling can be done here. Right? It also opens up what are the triggers. When you can say that say, do you have to do one time a day, or every day you'll have to do it, weekly, monthly, everything you can schedule here, right? And every time during that time, right, what you wanted to do, you wanted to run this particular script that I have created in Python. That also can be given here as input. That's all it is, right? But either your server can be a Windows server or a Unix server. Generally, these are the two flavors that we use, or a MacBook, right? So there is something called cron job, which I'm pretty sure you all know of, right? As academicians, you can set up a cron job to pick up this particular file and rerun it at various periods of time for you to run it, run this particular Python script that I've created, and that will become the batch mode. That's all it is. I mean, there is nothing Greek and Latin. You have persisted the file, and in the file, in the new file, which I saved here, I called it with some fancy name, right? Sunil, whatever it is, right? No, I saved it in, give me a second. I saved it in my Holy Cross FTP. I called it as Sunil model pickle run. And this file is what I'm scheduling either through Windows Task Scheduler or through cron job, right? And once I set up the cron job or Windows Task Scheduler successfully, it runs on its own on a period every day at a particular time that you've already set. So this covers the batch mode. However, real-time mode is slightly different, right? Real-time mode is about exposing your model as an API, right? API is like API is application programming interface, right? So basically, it is like you have a URL and you have a port number and you have an endpoint which you would use to hit with your data. And what this particular API does is it takes this particular input data and then it processes it at the server end. It does the predictions, and then this particular API returns your predictions to your client. Okay, so wherever you have called from, right? So your client could be a Java form, or it could be a JavaScript form or a .NET application. It doesn't matter. Although as long as you know the API's URL and IP address.
Sir,
and
sorry
port.
for the interruption. Are you presenting your PPT, sir? It's not visible.
I am presenting, madam. I am presenting my notebook. Okay, let me just give me a second. Can you confirm if you can see my notepad?
Yes, sir.
Okay, awesome. Thank you. So like I said, your client could be a Java form, a web application, or it could be a thick client. Thick client as in your application that runs on your laptop, or it could also be a mobile application. It could be anything, right? That is calling this API that is hosted on the server. And as long as you know the IP address and as long as you know as long as you know the port number and the format in which you need to send the request to the client, I mean to the server, and what format the response is received, as long as you know these details, you're absolutely free, right? You can call it from any application, any language, right? It becomes more like infrastructure independent, right? So now I'm going to demonstrate a quick thing to you on as to how client and server works for a machine learning model, right? And once that is done, I will walk you through the code, and I will also share all this code with you after the session, so you could practice it in the afternoon session, which is the practical, right? Okay, so I'm going to my I'm going to my command prompt, so I could simulate both my client and server, because I don't have two different systems. I have hosted my server and also client on the same system, right? So let's see. CD desktop. This is where all my files are located. Great learning. Um, um, all right. So so this is starting the server basically, right? So I have a server script that is written there. I'm going to run that particular server, right? So please closely observe what happens here. So I am running my server file through a Python command, right? Basically, I'm instantiating my server and making it ready to accept any requests. Okay. You can see that the production server has started now, and it is running on an IP address called 127.0.0.1, and the port number on which it is listening is 8111, right? So this is the development server that I am running for it to accept any requests from the client, right? So I am going to simulate the client. I mean, now that you know the server, right? It is localhost 8111. But my localhost also has a IP address. As long as I give you the IP address to you, you should be able to call this particular port number and the IP from anywhere. I can call it from anywhere. Say, for example, I'm going to simulate it from my system uh, because I don't have two systems. So I'm using one system, two windows to simulate it. Okay, but pay a close attention. I think you will get a fair idea of what I'm trying to do. Okay. So I have my client file also there. I will show you the client file later and how I will show you the server file later. But for now, just observe the input output. I'm running my I'm executing my client file from here. You can see something happens now, right? You can see that the moment I ran the client file, it actually sent some messages to the server, which was received at the server end. It did some predictions, and the same prediction was returned to the client, right? And this client can be anything, your mobile application, your web application, or your thick client, or your HTML form. The moment you click on submit button, it could basically come back with send the request to the customer, to the server, and the server can eventually come back with a response to the client, right? It's as simple as that. Nothing more than that. All right. So let's go ahead and look at now how client and server is coded. That way you'll get a clarity on what is happening. Right. So let me open the file and show you. Okay. So basically, I as a client, I should know who to connect to, right? My server IP address is here. I'm connecting to a local host on the port called 8111, right? So that, in fact, if you look at the server window, that is what it is started listening on. It is saying running on HTTP 127.0.0.1 8111. That is where it is listening. So that's the same IP address that I've used. Okay. And I'm saying my URL is this one. The /API is the endpoint. Where this is coming from, I will tell you later. Okay. I'm saying there is a library called request in Python. Import that. And basically this library helps you to connect to a remote host, right? And JSON is the format in which I exchange messages between client and server. All right. So that is also a library in Python. And I'm saying I wanted to predict the cost of a house, I mean, that is 2,400 square feet. I'm giving this as a dictionary in Python, and I'm taking this dictionary and converting it into JSON format with this command called json.dumps. JSON is the library name. Dumps is the command that converts my dictionary into into a JSON data structure, so I could communicate my message to the server, right? And I'm calling that particular JSON that was created as data. So I have my URL, which is nothing but what is the server IP, port, and the endpoint, preferred format in which you exchange your data, right? Here I'm saying there is this library called request. Take that particular request library and post it, right? Essentially, you have get and post, right? And I'm saying that connect to the server through post command, and also post this particular data to whatever is the server IP address that I have mentioned here, right? So it is one step that is connecting to the server and also sending the client data, which is nothing but 2,400 square feet to the server, right? And now the response actually, I mean, the request is actually sent to the server. If this particular command were to execute successfully, the server gets connected, and also your 2,400 square feet will get passed on to the server, right? The server now receives all this data, processes it at the server end, does the prediction as to how much is the cost of the 200 square feet, 2,400 square feet house, and returns a response to the client, which is this, right? And now the client basically receives the response from the server, and now that response is also in JSON format, which cannot be printed directly on the screen. So I'm parsing the response through this command called JSON, and I'm printing it. So that's the reason you see this response called 70,835. This 70,835 is the server response that I have received, which is the prediction for 2,000 square feet house. And because I have I have got a print command here, it has printed on the screen saying this is the prediction that I have received from the server. Okay. Now you know how the client file looks like, right? Let's go ahead and look at the server file. This is slightly going to be a little complex, but if you pay attention, it is super easy to understand, right? So this is all. This is the code that you would need to basically do your server setup in Python, right? Using Flask. So all that I'm saying here is, okay, there is a library called NumPy, which is for numerical processing of arrays or numerical processing of matrices. I'm saying go ahead and use this NumPy library. And I'm also saying there is a Flask library. From that library, import the Flask framework, import the request library, and also import the JSONify library. Okay. So these are required libraries. That's the reason I have done it. And I'm also saying I need to read the pickle file, right? Pickle file is my model that is persisted on the disk. So I need to be able to read it and load it to the main memory as and when this server is instantiated. So I'm having pickle and joblib. I hope you are able to see my screen. Can you confirm if my server file is visible?
Yes.
Okay, awesome. Right? And I'm also saying import.os, because on the server, there is a particular directory in which I have put my pickle file, right? I should be able to understand where my pickle file is, and I should be able to read it through, right? With the pickle.load command. So that's the reason even import.os is required. So now I'm changing my directory on the server where my pickle file is located with this command called os.chdir. Okay. And next thing that I'm reading is my pickle file with the command called pickle.load. Okay. So pickle.load, and I know my pickle file name, which is sunil.pros, and I'm reading it in read binary file mode, and I'm loading my contents of the file to the variable called model. So now model is in the RAM of your server. The moment this particular line of code gets executed in the server, Okay, so basically how does it get executed? It gets executed through Python server.py. Server is the name of the file that I've put. So when I run that particular Python server.py, when this line of code gets executed, the model which is there on a file called sunil.pras will now get loaded onto your main memory, which is your RAM, and it is now called as model. That is the name of the model. I mean, you can give it any variable name. So here I was convenient to, when I wanted to call it model, so I called it as a model. Okay, so this is where this part of the code is what is your exposing your model as your API. Up till here, you're just reading the model and making it ready for scoring, which was there in your file, you're reading it. But this part of the code is what actually does your reading the, exposing the model as API. That's all, just like 10 lines of code. So all that I am saying here is, this is called a decorator. I mean, these 2 lines is called a decorator. This is like main. I'm sure most of you are aware of C language, right? So there is a main. This is not a main. Basically, I'm saying that this is a Flask application, right? It is an application that is made of Flask. I am declaring that, right? And then this is called a decorator. Okay. The decorator says, what is your endpoint name? Remember our client file where we said my server name is this, or my server IP is this, my port number is this, and this is where my API is located, right? This is called an endpoint. With the same port, you can have tons of APIs, right? Here I am saying that this is the, you could name it anything, but I have named this particular API as API, right? This is the endpoint. That's the reason your URL at the client end has this. So the client side call has this particular /API is because in the decorator of the Flask application, I said this is going to be a endpoint called API that needs to be hit. Okay. And I am also saying this particular API that is hosted on this endpoint will only accept post requests. So that's the reason in the client you have used post rather than get. Okay. So this particular Flask API will only accept post requests. That is what I'm saying here. And then I'm declaring a function which basically accepts whatever is the data packet that is received from the client end. And I'm saying that you will receive a JSON. Go ahead and accept that particular JSON, right? You can see there is a library called request here, and use that particular request library to get the JSON from the client, right? And I've got that particular request from the client, and the client basically sent to me a post request which is called data, and that data is in JSON format, and I have accepted it here with this particular command, and that will get stored onto this variable called data, right? Now look at this particular data structure. Remember I said it's a dictionary. It has a dictionary will have key value pair, right? Square feet is the key and the value is 2400. And I'm saying I call that particular data that has come from the client as data, right? I'm referring to the data structure that was received from the customer or the client. And in that particular data packet, I have a key called square feet, right? And look at the square feet key and the corresponding value, and that will become your predict request, right? This is the square feet value for which I wanted to predict how much is the price, right? And I'm converting, I'm doing some typecasting here. np.array is nothing but your typecasting, which is basically converting your integer that was received into an array. So this is just typecasting, and I'm printing the predict request, right? So if you look at the server screen, this message called 2400 is because of this particular print predict request, right? What have you received from the client? I just want to demo it to you, so I have printed it. Next is very easy, right? You've already got that message of how many square feet price prediction you are interested in. And that thing you have already received and printed it on the server end. Now you are saying model.predict. Model is something which you have already loaded onto the RAM of this server. And you're saying model.predict. Predict is the command that will predict on the input called predict request, right? So here goes your 2400. You are saying, oh, hello model, go ahead and predict on this 2000 square feet and store that particular value that you have predicted in this variable called predictions. Okay. And that is what you are printing also here, right? Because of this print command, you can see it is actually outputting to 70,835 on the server. So look, this is the server screen. Okay. On the server, it is printing it as 70,835. All right. So now after that is done, what I have done is, if you look at the way printing is done, right? I mean, the data structure, it is a list item. It is a list, right? You have 70,000 as, observe it is 70,238 dot. So this is a data structure which is a list data structure in Python. But I don't want a list data structure. I wanted to return an integer or a float. What do? I pop out the first element in the data structure called list, which essentially returns you only this element. This is the first element, right? The zeroth element. The zeroth element or the zeroth index is the first element. That is what it is going to pop out, which is 70,835.6382, etc. And it is going to store it in a variable called output, right? And this output is what I'm printing on the screen. And that is because of the it is because of that print I am seeing here the 70,835, which is a float value. And now the communication between server and client has to happen, right? The client has already got connected to the server, and now the server predicted certain value, and it now knows what need to be communicated to the client, but I'm yet to communicate with the client. And there is a standard language that I need to use to transmit my data over the network to the client. How do I transmit it? I transmit it through something called JSON. To convert a float value into JSON, all that you need to do is typecasting. How do I do the typecasting? It is through this library function called JSONify, right? JSONify is nothing but converting your non-JSON data structures into, or data types into JSON. I converted it and I'm doing a return. Okay. And when I do a return, basically whatever is the predicted value, which is a float, gets communicated back to the client. Okay. And this is nothing but your main function in Flask application. I'm saying, okay, run everything here and run this particular Flask application on a port called 8111. You can see I'm saying run this particular Flask app. You have already told it's a Flask app, right? And I'm saying app.run, and I'm doing app.run on a port called 8111, right? So wherever this particular server, this particular application, wherever this particular application runs, that system's IP forms the first part of the URL. Right? Here I'm running it on my local system, right? So that's the reason it can be called as localhost or 127.0.0.1. Okay, it is like loopback address, right? And I have already hard coded my server IP address here called 8111. That's the reason that also need to be added to my server call 8111. And I have also specified the endpoint in the server, so which is nothing but the /API. So this also need to be added to the server IP address and the port /API. If you look at it, this is what I have put in the client file to say that, okay, this is where I need to get connected. So you can see that, right? HTTP localhost 8111 API. And how did it come? It came in because of the various components that I have laid out in my server file. You can see all of them are described here. This is the endpoint, and I'm saying the Flask application has to run on this particular file, this particular port, and wherever this Flask application is executed with this command called python server.py, that machine's IP is the IP of my server, right? It's as simple as that. I will do another demonstration. This is an asynchronous server. This will not die. This will keep listening. Once you run the server, right, it is always live unless you kill it explicitly. Okay. So what I'm going to do now is just to do another demonstration. I'm going to say what is the square feet of a 3,248 square feet house. Okay. Earlier we have predicted for 2,400. Now I'm going to predict it for 3,428 square feet. Again, I'm going to call Python client.py. Okay. So please observe what happens. Okay. I think I just need to restart the window here. Just give me a second. Okay, let's see if we get a response. Should not take so much time. Maybe server has gone into idle mode. Let me restart the server. Yeah, let me kill it and restart the server. Maybe it has gone into non-responsive mode. So how do I kill my server? It is through Control C. Oh, actually it has received. If you actually look at it, 3,248, it has received. We were too early to kill it. But anyway, so let me bring up another screen. CMD, Python, CD, desktop, learning, TechML. Deployment. Less Python server.py. So generally you don't have to do it again and again, but because my server has gone into non-responsive mode, I have restarted it. So you can see it has started again. So let me bring up another screen where I have to run my client. CD, desktop, deployment. You can see again, right? So the server now, when the client now has sent a message called 3,248 in JSON format to the server. The server processed it with this square feet was accepted by the server, and it processed everything, and it predicted saying that a 3,200 square feet, 248 square feet house cost $95,238. Thus, that $95,238 is now converted to float, and it got printed on the server, and that is the message that got returned to the client. And this client can now consume the information like for the downstream processes, right? I mean, ideally speaking, this client and server can be hosted on two different systems. The model is run on the server. It is exposed as an API, and the API is called by the client to get a response, right? As long as the messages are communicated with post and the data structure, the JSON data structure that the client passes to the server is in the right format, the server will take this particular information, processes it, and then it returns to the client, right? One more thing you may have to observe is As and when the client basically receives the response, it has ended, right? It has closed the connection with the server, but the connection basically is still live. But the server is still live. So which essentially means it can keep on responding to. It can keep on responding to multiple clients. You could have multiple clients serviced by the server at the same time. All the requests from the client will go and get queued. So this is where you could use MQ, or you could have a web server fronting this particular server that is written in Flask, etc. You could do all of that. In fact, you could use Kubernetes or you could host this particular Flask app on Azure or AWS or Google Cloud, and then you could use the Kubernetes module also, where if there is a lot of requests getting queued, right, you could actually replicate the server to have your server service to multiple clients also. So in fact, the reason I thought this will be a good topic for us to cover today is most of you, because of your academic background, you sometimes ignore how to productionalize the model kind of a framework. So that's the reason I thought this will be a good hands-on exercise for you to practice. And that's the reason I have touched based on this topic today. And it's a very important component, right? So nobody will appreciate your ML or data science unless you go ahead and productionalize your machine learning models, right? At the end of the day, the question is, well, you could be the dawn of machine learning. So what does it mean to the business? How much of an ROI are you breaking? Well, you could predict. So what does it mean? Are you able to productionalize the model and service to the business? So that is what industry cares for, right? And that is where productionalizing and learning about productionalizing a model is very important for data scientists, right? I think it's 12:45 almost. I'll pause here to see if there are any questions or anything is confusing, so I could help you learn that. And then in the afternoon session, I will pass on all these files so you could simulate all of this on your own system, and I can take any questions also at that point in time, just in case you need any help.
Sir, I have a doubt, sir.
Yes.
Sir,
Go ahead.
given that file name field.prab, is it a binary file?
Yeah, it is a binary file.
Because pickle module can be applied only for binary files. That's why I have a doubt.
No, you could name it whatever you want, madam, right? So, you could call it ajay.pras or ajay.xyz, anything you can call it. There is no restriction about it.
So, not necessary to use .dat, sir?
Madam, I'm not able to follow you. You're echoing quite a bit. Can you repeat your question?
Yes, sir. Actually, sir, the extension for binary files you should have .dat, isn't it, sir?
No, nothing like that, madam. Who said that, right? It's not that you need to have that extension called DAT. You could have any extension for any file.
Okay, so that doesn't matter, isn't it?
Yeah, it doesn't matter at all.
Okay, sir. Sir, you're using Flask here, sir?
Yes. I'm using Flask to expose my machine learning model. Yeah, you could use Django also, but Django is a little more complex and you need to have your own application server for it. That's the reason we didn't prefer Django here, but Flask is the most preferred mode.
Sir, one more doubt, sir. You were telling about JSON modules, sir. Sir, actually, I have a doubt. What is the use of JSON? Why do we go for JSON here, sir?
No, you could communicate with other modes also, right? But JSON is more of a XML format. I mean, you could communicate with XML also, but JSON provides extra security when you're communicating with the client.
So far, sir, I'm a computer science teacher, sir, working in school as PGT. So far, we have studied in Python, like JSON is used for formatting. That's what I had a doubt.
No, madam. JSON is also used to basically communicate with client and server. It is like XML, right? Or it's basically more of a standard format that can be universally understood.
So it's for client server communication, sir, basically.
Yeah, it can also be used for client server communication. It's not only for styling.
Yes, yes, sir. Thank you, sir. Thank you, sir.
No problem. All right. Any other questions? Anything that is impeding in your minds? Wow, very silent crowd.
Participants, if you have any doubts, you can clarify with me.
All right. So either I have done extremely well in the session or I have done extremely poor that I confused all of you so you don't have any questions. So that's the conclusion that I'm coming to. So you
No,
need
sir,
to tell
there is
me
a
which one is
comment in
correct.
You have
chat
done
box
very
that
well, sir.
it
You
was
have
an
done very well.
amazing session.
Okay.
Sir, very informative session, sir. Really very good session, sir. Thank you,
Yeah.
sir.
Yeah. Thank you so much. Good to
Can
see
I ask
that.
something?
Yeah, absolutely, Mr. Devesh. Go ahead.
Yes. First of all, I must congratulate. That was a wonderful session, and we have used a little bit of ML and all these things. But you were right that mostly in the academic area, we are not thinking about the practicability of the technique. So I was wondering that what if it's just a scenario that suppose there are n number of employees of a company, and while meeting the client, they directly have to interact with the client, and they have to give an estimate about the costing of the property. Let's say they enter that amount in their handheld device or an Android application, and this model, which is available through their website, immediately is responding. So is it practical and possible?
Yeah, it is possible, sir. So what we do is we generally, I mean, when you say costing, are you talking about the infrastructure costs or you
No,
talking
no, no.
about
I'm talking about just plain and simple, the demonstration that you just given, that if I enter the square feet area of a property, and that lets me know that, okay, what will the approximate value of that? Just two parameters.
Yes.
So, like you have demonstrated it's in the form of a server and client model working from two systems. So I'm saying, what if there are n number of clients and they all are using their phones to connect to the server?
No, absolutely fine. So that is where your Kubernetes comes into picture. Now, let me show you. I don't know if you are able to see my screen still.
Yes, I
Are
can
you?
see
Yes,
that.
sir. The
Okay.
screen is visible.
Yes.
Okay, super. So let me go here. So you need to read about something called Kubernetes. So one of the things happens with Kubernetes is scaling also, right? Auto scaling for that matter. So what we do is, so this Kubernetes component exists on all of the Google Cloud, AWS Cloud, Heroku, AWS, Azure. All of these cloud platforms do come with this Kubernetes module. Okay, so when I'm talking about this client server thing, right? This only one instance of the client server is running at the moment. Um, because I've instantiated only one server instance. What Kubernetes does is it keeps a monitor on the incoming loads. And if there is too much of an incoming load coming, what Kubernetes automatically does is it replicates the server module into multiple modules and brings them up. So there is workload distribution that automatically happens through Kubernetes, and all your client requests get serviced simultaneously. So that is what happens with the Kubernetes module, Mr. Devesh. So that's how we service it. And this is also a good way, right? So why Kubernetes way of doing scaling is better than having 10 servers established. So there are times where you have huge loads, right? So for example, during business hours, there is a lot of NEFT or RTGS transactions. But during non-banking hours, the load gets reduced, right? You don't want to have 10 servers sitting in RBI doing loads. I mean, you don't want to buy 10 servers. Rather, what I do is I install Kubernetes on one server, and I will have it take care of replicating multiple servers using the same infrastructure. So that way you don't have to buy 10 physical servers. It's just one physical infrastructure is good enough. The logical layering is taken care by Kubernetes. I hope that answers your question, Mr. Devesh.
Yes, perfectly fine. Yes, I understood the concept.
Yeah.
Thank you so much.
No worries. Yeah, so I can actually give you this link just in case you wanted to understand better. Yeah, somebody seems to have asked me for it. Yeah, Mr. Shivam. Yeah, here you go. Okay, so I mean, all of this Google Cloud platform or Google Cloud, Azure, all of these platforms, right? I mean, I'll give you some platform names here. Say, one of the things that you could experiment is how to host a model, which I have not touched base in this session, right? Because it takes longer time. Heroku, Azure, AWS, Google Cloud, or even Saturn Cloud. All of them also provide free tires. You can go ahead and register there. They will give you some free tires to go ahead and experiment. What you could do is you could build a model, build a Flask application, and export it to one of these clouds and use Kubernetes that is available there in order to host your machine learning model. It will also give you an external IP for you when you host the model there on cloud. Using this external IP, right? Now I have simulated both client and server on my local system. What you could do is once you put it on on one of these cloud servers, you could ping it, or you could basically have your client anywhere in the world and still be able to use that external IP, the port number, etc. Right? And this cloud platforms will automatically take care of giving you an external IP as well as auto scaling. Right? I would strongly urge, if you want to be a practitioner in data science or machine learning, this is a very important skill you need to have. So this area is called as ML Ops. Just go ahead and browse through some of the documents. I'm pretty sure it's an exciting area that you could teach your students as well. And this is where a lot of jobs are even expected in India in the next 5 years, ML Ops. This is a combination of ML plus data engineering plus data engineering. DevOps. Right. So this is a new gen thing that is coming up very recently, and you could help your students by teaching this. They will be job ready as well. All right, cool. Any other questions? All right, awesome. We are on time. So what we do now is we will take. I will hand over to.
Shall we wind up the session, sir?
Yes, we can.
Yes, thank you, sir.
Last session we can start at 2 o'clock, sir.
Yes, what I would do is it's a practical session, right? I will send all these files to. I'll send all these files to you, so people can go ahead and experiment it on your laptop. You can distribute these files to them.
Sure, sir. Please send it to my WhatsApp, sir.
I will do that.
Yes, thank you, sir. Thank you, sir.
All right, cheers, everyone. I'll see you at 2 o'clock. Bye-bye.
Thank you so much, sir. Yadal, take up the.
Yes, ma'am. Yes, ma'am. Dear participants, I hope this morning's sessions were informative and useful. Meet you in the afternoon for the hands-on session on data analysis through R and Python. Please be back at 2 o'clock sharp for the third session. Thank you.